Hello, aspiring software developers. Welcome to this essential module on API diagramming and flow explanation. In today's interconnected digital landscape, understanding application programming interfaces, or APIs, is not just beneficial, it's absolutely fundamental. APIs are the unsung heroes enabling different software systems to communicate, interact, and exchange data seamlessly. Think of an API as a contract or a blueprint that defines how one piece of software can talk to another. It specifies the methods, data formats, and protocols that developers must adhere to when building integrations. Without them, our modern applications, from your favorite social media apps to complex enterprise systems, simply wouldn't function as they do. Our primary focus today is on visualizing these interactions through API diagrams and understanding their workflow or flow explanation. Diagramming is a powerful technique that allows us to abstract complex processes into comprehensible visual representations. It's crucial for system design, troubleshooting, and stakeholder communication. Let's demystify the process by walking through a common API interaction scenario. Imagine a client application, perhaps a mobile app or a web-based front-end, that needs to retrieve information from a back-end service. The user initiates an action, say clicking a Get Product Details button. This action triggers an API request. The client constructs an HTTP request targeting a specific endpoint, essentially a unique URL that points to a particular resource or function on the server. This request will typically include parameters like a product ID and often an authentication token for security and authorization. This request often first hits an API gateway. An API gateway is a management layer that acts as the single entry point for all client requests. It performs vital functions such as request validation, rate limiting to prevent abuse, load balancing to distribute traffic, and routing the request to the correct backend service. Once routed, the backend service, which houses the core business logic, receives and processes the request. It might interact with a database to query data, perform computations, or update records. This is where the actual work of your application happens. After processing, the backend service generates an API response, typically formatted as JSON, JavaScript object notation, or sometimes XML. This response payload contains the requested data and an HTTP status code, indicating the success or failure of the operation. This response then travels back through the API gateway to the client application. The client application then parses the received data. It checks the status code for any errors and, if successful, updates the user interface to display the information. This entire round trip constitutes a single API interaction. When we talk about diagramming, beyond simple box and arrow diagrams, UML, Unified Modeling Language, sequence diagrams are incredibly effective for illustrating the chronological order of interactions. Each vertical line represents a participant or object, and horizontal arrows depict messages or method calls exchanged over time. This provides a clear trace of the execution flow. Other useful diagrams include UML state diagrams, which illustrate the different states an object or system can be in and the transitions between them, or traditional flowcharts, which are excellent for mapping out decision trees and conditional logic within an API's operations. So what are the effects of effective API diagramming? Firstly, greatly enhanced clarity and comprehension for all team members, regardless of their technical depth. Secondly, improved collaboration and communication between front-end, back-end, and QA teams. Thirdly, it significantly aids in identifying potential bottlenecks, design flaws, and edge cases early in the development lifecycle, leading to more robust and scalable solutions. It also serves as invaluable documentation for future reference and onboarding new team members. Let's review some of the key vocabulary we've covered today in context. API, Application Programming Interface, a set of defined rules that enable different software applications to communicate. Endpoint, a specific URL where an API can be accessed to perform an action or retrieve data. HTTP request, the message sent by a client to a server, typically using methods like GET, POST, PUT, DELETE. Parameters, data passed within an API request to filter or specify information. Authentication token, a credential used to verify the identity of a user or application. API gateway, a management tool that acts as a single entry point for API requests, handling routing, security, and more. Back-end service, the server-side logic that processes requests, interacts with databases, and performs core functions. Database, an organized collection of data, typically stored and accessed electronically. JSON, JavaScript object notation, a lightweight data interchange format, commonly used for API responses. Response payload, the data returned by an API in response to a request. HTTP status code, a 3-digit code indicating the outcome of an HTTP request, e.g. 200 OK, 404 not found, 500 internal server error. Parsing, the process of analyzing and extracting information from structured data. UML, Unified Modeling Language, a standardized system for visually modeling, specifying, constructing, and documenting the artifacts of a software system. Sequence diagram, a UML diagram showing the order of interactions between objects in a chronological sequence. Collaboration, working together to achieve a common goal. Scalable, the ability of a system to handle a growing amount of work by adding resources. Robust, capable of withstanding adverse conditions or maltreatment. Documentation, written materials that provide information about a product, system, or process. Onboarding, the process of integrating a new employee into an organization or a new user into a system. Bottleneck, a point of congestion in a system that impedes overall progress. Edge case, a problem or situation that occurs only at an extreme, maximum, or minimum operating parameter. Development lifecycle, the structured process of planning, creating, testing, and deploying an information system. Mastering API diagramming and understanding the underlying flow is a critical skill for any developer. It empowers you to design, debug, and deliver high-quality software solutions that are not only functional, but also maintainable and extensible. As you progress in your training, actively practice creating these diagrams for the systems you build. This foundational knowledge will be an invaluable asset throughout your career. Thank you for joining us for this module. Keep learning, keep building, and keep connecting. See you in the next session.